Good evening, everybody. Welcome to Chem 1211 with your host, me, Dr. White. How you doing? Tonight, I'm going to do a review for Quiz 5. But before I do that, let me just quickly remind you, hand in the labs. I extended the amnesty program through the 15th of May. Remember, and I put out a announcement. Let's go to Blackboard. This is important enough. Actually, I should have moved this up higher, and I'll do that right now. Let's first do this. I thought I had it in the email here. No, I guess I didn't. All right, what I can tell you is don't forget the hand in your labs. If you don't get 65% of the points, total points for the labs this semester, you can't get a C or higher in this class, no matter what you do on the test. It's in my syllabus. So make sure you hand in labs. All right, let me remind you that this Thursday on the 8th at 8 a.m. or earlier, I'll send out the password for Quiz 5 PDF file. You'll have on Friday, 8 p.m. to upload your answers to Quiz 5 as a single PDF file. Check to make sure you can open it, because if you can't open it before you upload it, I can't. And remember, I reserve the right to subtract up to 25 points from your Quiz 5 point total for anyone who does not follow instructions or does not upload your Quiz 5 answers on time. Again, Quiz 5 has 4 pages, 9 problems. Some are multiple part, no multiple choice in this quiz. It's worth 50 points. It covers chapter 15, which is equilibrium, including the collision theory of reactions, rate of reactions, chemical equilibrium, and Le Chatelier's principle. All right. One other thing, let me get a calendar up, and I'll be putting out a video later on this week. Coming up is finals week, and you'll have on Saturday, the 17th of May, the 19th, 20th, and the 21st of May to take my test 2 and the standardized Chem 1211, or it's the ACS final exam. Now, I'd highly recommend, one, take them both at the same time you go to the testing center in Glen Ellen. You can only take it at the testing center at Glen Ellen. 2, take my test 2 first. You'll be given 2 hours, but most students are done in 60 minutes. Then, when you get my test 2 or you're in line to get it, tell the person at the testing center you're also going to take at the same time the ACS final once you're done with your test 2. That way you don't have to go outside and get back into a long line and wait. Last semester, they were nice enough to give students who took them at the same time, just go back to the desk when you're handing in your test 2, then they'll give you the ACS final. And that's a 55-minute time. So that gives you a block. Now, the other thing is during finals week, that's Saturday, Monday, Tuesday, and Wednesday, it's going to get busy in there. One, Go early in the week, Saturday or Monday or Tuesday. Don't wait until Wednesday. Go early in the morning when it's not as crowded. The other thing is, if you're taking a test that takes, let's say, an hour, and there's less than an hour before they close, they will not let you take that test. I'll say that again. If you're taking a test that takes an hour or 55 minutes, and there's less than an hour or so before they close at the end of the day, they won't let you take that test, which is why I say go in the morning. You won't have that problem. Also, go earlier in the week in case there's some problems and whatever, and you'd have to come back. Hopefully, that won't. Uh, the manager of the testing center, Lori, has done a fabulous job, and her personnel have always treated my students with respect and done a great job. But you have to go there early, it'll make your life easier. All right, let's go through the review for quiz number 5. Now, if you go to the lecture section of Blackboard, you'll find a file called Chem 1211 Quiz 5 Review. I have both as a Word document and a PDF file. All right, let's go through. First thing you should know is the collision theory. And the collision theory of chemical reactions, the first thing you should know, in order for a chemical reaction to occur, molecules must collide for a reaction to occur. The next thing is when you have that collision, colliding molecules or atoms and molecules must have a minimum amount of energy called the activation energy for a chemical reaction to occur. And for certain complex molecules, they must occur in the proper orientation, like they come together like this, not like this where they don't fit together. They have to have the proper orientation. And you should know these 3 aspects of the collision theory. Now, next we talk about the rate of a reaction rate or rate of a reaction. That's the rate at which products are made or reactants are consumed. Consume means used up. Now, you should know what factors influence the rate of reaction, how fast the reaction is going. One is the physical nature of the reactants. Gases react much, much faster than solids mixed together. The reactant's concentration, how much of a certain reactant, the more of them, the more collisions, the faster. Now, this is very important. Have you figured out by now when I put something in red, it's important? And that's the reaction temperature. And there's an important rule of thumb. Oh, it's on this thumb. Can you see? A rule of thumb means it's mostly true. A law is always true. And that rule of thumb is the rate of a chemical reaction doubles for, and this should be every, there's an E missing there, for every 10 degrees C increase in the reaction temperature. When you increase the reaction temperature by 10 degrees, the reaction rate doubles. Now, one other way of making a reaction go faster is using a catalyst. And a catalyst, how does a catalyst work? And you should know a catalyst works by lowering the activation energy. By the way, your enzymes are catalysts in your body. So a catalyst works by lowering the activation energy to increase the reaction rate. Now, there's 2 important things you should know how to do. Draw the energy diagram For an exothermic reaction, that means one that heat's given off. And for an endothermic reaction, that's where heat is added. And let's take a look at that. Oops, got to open up something first. And this is an exothermic reaction. How do you know? Heat is made. Remember, for a reaction, at the base of the arrow are the reactants. If I can spell, did I tell you I was first one down in spelling bee? And at the head of the arrow are the products. And you should know that. So what is an energy diagram? It's a graph of energy versus time. And let's assume at the beginning, A and B have a certain amount of energy. Now, there's a rule of conservation of energy. That's not the right name, conservation of energy. I guess it is, that you never create or destroy energy. So the total energy on the reactant side equals the total energy on the products. But some of that energy is lost as heat. So that means C and D have less energy than A and B. Now, how do you go from A and B to C and D? You go over the hill and down the hill to grandmother's house we go. Actually, just go over the hill. And you should know from where you start here to the top of the hill is called the activation energy, abbreviated EAC. And you should know that. And remember, since heat is lost, C and D have less energy than A and B. Because the total energy on the reactants A and B equals the total energy of C, D, and E. Now that's an exothermic reaction. Let's look at a endothermic reaction. Now here we have to add heat on the reactant side. And now here, the total energy of the reactants and heat equal the total energy of G and H. And the energy diagram is still this, where on the x-axis is time. Some books call it reaction coordinates. I just call it time. And on the y-axis is energy. Now, because the total energy on this side equals total energy of this, G and H will have more energy than E and F. because the energy in G and H is also includes the heat, where E and F doesn't have that heat, you're adding it. So you have the same over the hill and down the hill to grandmother's house we go. And from where you start to the top of the hill, again, is the activation energy, abbreviated that. And this is an endothermic reaction because you have to add heat, and that makes E and F less energy than G and H, because G and H has all the energy in E and F plus the energy of heat. So these are the two diagrams you should know how to create. And also remember, from where you start to the top of the hill is the activation energy. And catalysts lower that so it's easier to get over the hill, make a reaction quicker. Now, in chemistry, there's an important type of reaction called an equilibrium reaction. And an equilibrium reaction is a reversible reaction. Let's say A plus B, and you see the double-headed arrow like I have, makes C plus D, but it's going both directions at the same time. And when you have chemical equilibrium, that means the forward and reverse reaction rates are the same. Again, it's reversible. It goes to the right to the left and the left to the right at the same time. And there are a number of reactions going on like this in our body that this equilibrium helps keep us alive, which I think is a good thing. Now, there's a special constant called the equilibrium constant. And the equilibrium constant, which is abbreviated capital K, subscript EQ, constant, that's what the K is, EQ is for equilibrium. And if you have a reaction, equilibrium reaction, that's balanced, and you have W moles of A plus X moles of B, making Y moles of C and Z moles of D, the coefficients are molar relationships. The equilibrium constant is the concentration of each product to the power of the coefficient. And these are time. Notice here we have a plus sign there. Students think there should be a plus sign there. No, it's time. Divided by the concentration of the reactants to the power of the coefficient A to the power D of W times B to the power of X. Now, when you put it in a bracket, and I say concentration, we're talking about moles of liter. So this is moles of liter of A, B, C, and D. And you should know how to write the equilibrium constant. Now, the equilibrium constant tells you something about the completeness of the reaction to one side or the other. And the larger KEQ, the equilibrium constant, the more products. If KEQ is greater than 1, sometimes you'll see me write two of these, much greater than 1. The constant amount or concentration of the products is greater than, remember this means greater than than the reactants. If K EQ, the equilibrium constant, is much less than 1, then the reactants there should be a C there, are much greater concentration than the products. And you should know this. Finally, there's a very important principle that you should know, and that's called Le Chatelier's principle. An equilibrium shifts to the side to reduce the stress put on the equilibrium. And you should know how to predict which way the equilibrium shifts, to the right or the left, based on concentration effects and temperature effects for both endothermic and exothermic reaction. And let's look at this. We have this chemical equilibrium. A plus B is an equilibrium. Remember, the double-headed arrows tells you it's in equilibrium with C and D. And let's make this an exothermic reaction. And therefore, on the right, you see heat also. What happens to the concentration of A and D if I add more B? In other words, if I increase the amount of B there, what happens? Well, here's how Le Chatelier's principle works. At equilibrium, there's a certain amount of A, a certain amount of B, a certain amount of C, and a certain amount of heat. When I add more B, what's the stress? Oh no, we have too much B. We have to get rid of it. How do we get rid of B? A reacts with B to shift the equilibrium there. When something reacts, it's consumed. And therefore, when it consumes, the amount decreases. There's less. Now, A and B are reacting to get rid of the excess B. What do? They make C, D, and heat. And when you make more of something, guess what? You're going to have more of it. So the amount of D will increase. Or increases, goes up, because A and B are reacting to get rid of the excess B. When they do that, they make C and D and heat. When you make more of something, the amount you have increases. Now, there's something you should know, and that is an ice bath removes heat. An ice bath removes heat. So if you put something in something cold, it removes heat. Now, boiling water bath, we all should know H2O is water by now, adds heat. When you put a reaction, say in a test tube, in a boiling water, and you all should have done Le Chatelier's principle to see that happen, boiling water bath adds heat. So let's look at the following chemical reaction. See if I can do something because I'm lazy. Nah, I'll just rewrite it. And let's look at the following. For this reaction again, A and B is in equilibrium with C, D, and heat. What happens to the concentration of A and D if I put the reaction in a boiling water bath? Well, what does a boiling water bath do? Well, it says right here, it adds heat. At equilibrium, there was a certain amount of A, certain amount of B, certain amount of C, certain amount of D, and a certain amount of heat. By putting it into the boiling water bath, we're adding heat. And it shifts to remove the stress. And what's the stress? At equilibrium, I have some certain amount of heat. Now, oh no, we have too much heat. We've got to get rid of it. How do we get rid of the heat? C, D, and heat react to make more A and B. Again, when something reacts, it's consumed and there'll be less. And that's how you get rid of the excess heat. So when something is consumed, reacts D, what happens to the concentration? Remember when I put it in brackets, that means concentration. It will decrease or decreases, goes down. Now, C, D, and heat are reacting to get rid of the excess heat. And what do they make? More A and B. And when you make more of something, the amount you have increases. So the concentration of A increases. And that's Le Chatelier's principle. And I want to say, I think your lungs and your kidneys use that to help do what they do, whatever your lungs and kidneys do. I'm a chemist, not a medical doctor. But anyways, that's it. Remember, this Thursday, I'll be giving quiz 5 I'll send out the email with the password for the PDF file you download from the assignment area Blackboard. You'll have until Friday, 8 p.m. to upload, I like the special effects, upload your, that was hokey. But anyways, upload your answers to Blackboard as a single PDF file. If you don't, I'll take off points. I did on quiz 4 to 2 students. And don't forget, hand in labs. I extended the amnesty program till May 15th. You have the rest of this week and next week to do your labs. And a number of you are missing one or more labs. Remember, if you don't get 65% of the points, you can't get a C or higher in this class. That's the departmental rule, not only for my class, but all chemistry classes, both online and face-to-face. So be sure to hand in your labs. If you have any problems with labs, reach out to me and I'll help you. You know, it's been true all semester. There's no such thing as a dumb question in my class. And with that, you know what I'm going to do next? I'm going to say, "Gehen gesund," which is Yiddish for go in health. I started doing that when COVID got bad. And also, I'm going to say, I'm going to stick, first of all, I'm going to stick around for a couple of minutes if anybody here has any questions. And now I'll say, bye. And I stole that from Granny to Beverly Hillbillies. Bye. Bye now.